Hello everyone, myself X Nancy, Assistant Professor of CSC Department in Veltech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College, Chennai. I am here to give a lecture on equivalence of CFL and PDA, which is covered in third unit of the subject CS6503 Theory of Computation. Now, let's move on to what is the procedure of deriving the equivalence of CFL and PDA. Basically, the equivalence of CFL and PDA consists of two types. That is, one is CFG to PDA and the other is PDA to CFG. First, we can move on to the topic of construction of PDA from CFG. That is, we are going to construct the PDA from the given grammar. Here we have basically four steps. The step 1 is to convert the given grammar to CNF, which is Chomsky normal form, in which we'll eliminate all the useless symbols, null productions, unit productions, and convert it into the format of non-terminal producing two non-terminals or a non-terminal producing a terminal. Our second step is to push start symbol into the stack. Our third step, it deals with the production that is given in our CFG. Whether the right hand is a combination of non-terminals or a right hand is combination of terminals, that is a terminal. In step 3, if the production is of the form S produces AB, which says that our start symbol is going to produce a combination of non-terminals, then we need to push this AB onto the stack. Whereas in step 4, if you are having a terminal at the right end, we are going to pop out from the stack. For making it more clear, here is an example. If S produces AB, the push operation is performed. This denotes that it is a transition function Q0 WS, whereas our Q0 is our initial state, W is our string, S is our start state, because S is given here, and then it produces Q0 comma AB. This shows that the AB, the combination of non-terminals produced by S, is pushed onto the stack. Or else, if S produces small a, which denotes that it is a terminal, the pop operation is performed. The transition function for this is given as Q0 AS produces Q0 comma epsilon. This epsilon denotes that we are going to pop the value from the stack and make it empty. Now we can solve our example problem. Our question is to construct a PDA for the following grammar. S produces AB, A produces CD, B produces B, C produces A, and D produces A. This shows that the first two productions shows our step 3. We can use step 3, and remaining 3 steps we can use our step 4. So now we are going to construct our PDA with initial configuration. At first, initial configuration is given as the transition function Q0 epsilon Z0 produces Q0 S Z0. This specifies that the Z0 is our input stack symbol and S is our start symbol, whereas our Q0 is our start state. I am going to move the start symbol into my stack and push it down. Then, based on the rules given predefined, based on the rules that are suggested for converting CFG to PDA, we are going to follow the same rules here. That is, if we find any production of non-terminals, we are going to perform push operations, whereas if we find any terminal, we are going to pop it out. Here, the first production is S produces AB, which can be written as Q0 WS produces is equal to Q0 AB. That is, AB is pushed onto the stack. Whereas the second production, A produces CD, here likewise like previous, I am going to push CD to the stack. Whereas for the remaining 3 steps, I am having my terminals at the right end, so that I am going to pop it out and make it as epsilon. That is, I am going to pop it out and make the stack empty. So now we can derive any grammar from the given, any string from the given grammar. For example, I am going to consider S produces AB. Instead of this A, if I substitute CD, instead of C and D, I am going to substitute AA. For B, I am going to substitute B. So I can use my string as AAB. For the given string, I am going to simulate that string in this following PDA, the converted PDA, and I am going to check whether the string is accepted or not. So here, initially for simulating the string AAB, as I already said, initially the transition function epsilon Z will lead to S Z0. Already we know that, we have explained it before. Now I'm going to place the input string W on input date. My input string is AAB. I'm going to substitute here. So transition Q0 AAB comma Z leads to Q0 AAB comma. If my Q0 is I need to check out what is my answer in the rules. So in my rules, if I consider Q0 WS produces Q0 comma AB. So I'm going to use, instead of S, I'm going to push AB. So instead of A, again I'm going to push CD. Instead of if I'm finding C, I can substitute my A here. I'm going to have my terminal here. I'm going to pop it out because C produces A. As we already know, C produces A. I'm going to substitute A for C and I'm going to pop it out. Again for D, I'm going to substitute A and pop it out. Again for this capital B, I'm going to substitute small b, and now I'm going to pop my B, and then finally I'll get my epsilon. This denotes that my string is accepted by the derived PDA. So that's all about my grammar to PDA conversion. Next we can move on to our PDA to grammar conversion. So here I'm going to construct my CFG from PDA. Here I'm going to construct using my tuples. I already know what all tuples. I'll have it here in PDA. So this denotes that let P is a PDA. There exists a CFG G which is accepted by PDA. That is, if I'm going to find a grammar, whatever the string is accepted by PDA, it should also be accepted by my CFG, that is derived. So here, as in previous conversion, here we have 3 steps. The initial step, step 1 is if Q0 is start state of PDA and Q1 is the final state, I need to write a CFG like Q0 Z Qn. If I have more than one state, then I'm going to substitute my whatever states I have, I'm going to substitute it instead of Qn, and I'm going to form some grammar. Considering S as my start state, I'll write it as S produces Q0 Z Q0, Q0 Z Q1, etc. In step 2, if the production rule is in the form, if my grammar is of the form, my PDA is of the form QI A Z0, and in the right hand side QI plus 1 Z1 Z2, that is, if I have the combination of non-terminals, I need to use my rule as transition function of QI Z0 QIK produces AQI plus 1 Z1 QM Z2 QI plus K, where I plus K and QM represents intermediate states. That is, if I have my state as Q0 and Q1, I need to substitute QI plus K for the first 2 productions as Q0 and second 2 productions as Q1, whereas I'm going to substitute Q0 Q1 alternatively for QM. When considering step 3, that is, if I am having my terminals, I need to just produce it from my left hand side. That is, this is same as to that of my previous conversion, the reverse process. Now we can see move on to our problem. So this is our question. Our question is obtain CFG for the PDA. Here I have Q0 Q1 as my state, 0 1 as my input symbols. A Z is my stack symbol transition function, Z is my input stack state, and Q1 is my final state, where transition function is given as, I'm going to consider these PDAs as R1, R2 and R3 for my easy convenience of solving. So as I said above, now I'm going to consider this as R1, R2 and R3. Initially, the first PDA statement is given as R1. It can be converted as, I'm going to substitute my formula, that is my rule given in my steps. Initially, I'm going to use this step or this step for converting it into CFG. Now, first, Q0 0Z, Q0 AZ. This shows that it is a production of non-terminals. For this, initially I'm going to have my QI plus K as Q0 and then Q1 as Q0 Q1. So this vertical bar shows that it is 2 productions. This is the first one, this is the second one. Initially I'm going to substitute my QI plus K as Q0. Here if you see, my QI plus K is here. That is, after Z0 I have my QI plus K, and then after Z1 and Z1 I have QM following by QM and ending in QI plus K. So here I will have my Qi plus K here, Qm here, Qm here, and Qi plus K here. Likewise, I'll follow with the producing. I have two states, Q0 and Q1, so that I'll have my Qi plus K, Q0 as constant for these two steps, and I'm going to change my Qm for these two productions. Likewise, I'm going to convert it for the next one. Here, I'm going to convert my Q0 into Q1 and substitute it in the given production based on my rules. Then I'll get my 4 productions from this R1. Likewise, I'm going to substitute it for R2. Qi plus K, Q0, Q1, Qm is Q0, Q1, Q0, Q1. So I'll get 4 productions from here. And in R3, I'll use my step 3, in which I'll have my terminal at the middle, and I'm going to have my epsilon at the right hand, so that I will move my terminal to the right hand side. So now here I have a terminal, here I have a epsilon, so this denotes that it is my third step, and then I'm going to just move to the right hand side, move my terminal to the right hand side. So therefore, the equivalent CFG can be written as step, because of step 1, I'm going to write it as CS produces Q0 Z Qn, and then the rest of the things I have derived all the productions from using my rules, and then I have written all those things. For me, making it more clear, I can even substitute a variable for this type. Q0 Z Q0 can be written as Q0 Q0 can be written as B, so that I can use my CNF technology, that is my eliminating all useless symbols, and derive a perfect CFG for the given PDA. So that's all about converting. Thank you. So thank you all for watching this lecture. I hope you all understood the equivalence of CFG and PDA. So as to convert from either CFG to PDA and PDA CFG is more easier after listening to this lecture. Thank you all. Thank you.